All right, let us see some more examples. Okay, so here there are some problems in your online homework. There may be, okay, some problems in your online homework where if y equals to f of x, then you can write x equals to f of y, the other types of problem, right? Because you see that usually we used to have fx and then x will be on the right hand side and x will be on the right hand side, but there you see that y squared, this is a function of y, so you can denote this by x. Okay, you can denote this by like x equals to and then another x equals to, like that. Okay, in that case you see that it is like x equals to y squared, because if there was fx we would write y equals to x squared, like that. Since this is fy, so you write x equals to y squared and x equals to y plus 2. So to draw the graph you can do like, you solve for y will be plus minus root x, right? So for the plus it will be this graph, for minus it will be that graph. And if you solve this for y, you will get y equals to x minus 2, right? That will be the y equals to x minus 2. So you can draw the graph like this, but the idea is similar. So if it was y equals to fx, then you would need the limit for x. But since this is fy equals to y squared and gy equals to y plus 2, you need limit for y. So you see that what is this point? You want to find out that. You want to find out that y value and then to that y value. You need to find out those. Okay, so we need to solve them first and find the y values. Previously we were needing x value. We were needing x values. Now we need y value because there is y on the right hand side here. Okay. So let us solve this equation and that equation, because at this point and that point these two functions are same, that two graphs are the same. So you write y squared equals to y plus 2, that is subtract this from both sides, you will get y squared minus y minus 2 equals to 0, right? So y minus 2 and then y plus 1 equals to 0. So y is equals to 2 and negative 1. Okay, so you are basically looking on this way, you are looking on that way. Okay, which side, which curve is on the top? If you look that way, it will be like, because this is previously, this is like it used to be, because if you rotate this, you will look like this, right? You will look like this, right? If you rotate it, so that is on the top side. But if you look from this direction, from that direction, this is on the top and that part is on the bottom in that interval. So that will be negative 1, positive 2. So the area equals to negative 1 through 2, and then you have y, not y square, y plus 2, right? Y plus 2 is on the top, and then minus, because you see that if you find out the area under G, that will be the whole area. If you find out the area under F, that will be just that white area, So you are subtracting the white area from the whole area under G. Under means that's basically the left of G. So area left of G minus area left of F, that will be the shaded region. Okay, because we have function of y. Okay, minus y square and then dy. You see that dy, and we are putting the limit of y's, not x. Okay, this is y equals negative 1. And this is y equals to positive 2. Okay, now integral this y squared over 2 plus 2y minus, how much is that, y cubed over 3, and then negative 1 through 2. Now plug in 2 first, you will get 2 squared is 4 over 2 is 2 plus, by the way this is y, right? 2 plus 4 minus 2 cubed over 3, 8 third minus, now plug in negative 1, 1/2 minus 2 plus 1/3. When you plug in negative 1, that's what you get, because you see that negative 1 square is positive 1 over 2, 2 times negative 1 is negative 2, and minus negative 1 to the cube is negative 1, that will make it positive 1/3. Okay, so if you do that, you will get 6 minus 8/3 minus 1/2 plus 2 minus 1/3. See that? So that will be how much? That will be 6 plus 2 is 8, and then minus 8/3 minus 1/3 is minus 9/3, that is 3, and then minus 1/2. That is again 8 minus 3 is 5 minus 1/2 is 9/2. That is 5 minus 1/2. Okay, 9/2 is 4.5. All right, that was all about finding the area between two curves if they do not intersect inside that interval. Now the next thing we want to do is we want to find out the area between two curves intersecting inside that interval AB. Okay, we want to find out the area between this curve fx and gx inside the interval A to B, but there is an intersection there. You see that the tricky part is on the left piece, on this shaded region, f function is on the top and g function is at the bottom, so you will do fx minus gx. And on the right piece, on the right shaded region, g is on the top and f is on the bottom. Okay, so we will do gx minus fx in the integral. You see that fx and gx are intersecting at x equals to c. So in AB interval, the area between f and g is area equals to a to c, where fx is bigger, that's why fx minus gx dx, plus in c to b, gx minus fx, because gx is bigger than fx in that interval. That's the idea. Okay guys, let us do this example, which is question number 22 from the book. Find the area between fx equals to cube root of x minus 1 and then gx is equals to x minus 1. If you draw the graph, this is what you get. Okay, all right, so first of all we need to know where they intersect. We need to find out this point, that point, and that point. We need to find out this point of intersection. How? Because at these 3 points, these curves fx and gx are equal, right? That's why we are doing cube root of x minus 1. Cube root of x minus 1 is equals to x minus 1. Now cube on both sides. What do you get? X minus 1 equals to x minus 1 square. So how do I FOIL this x minus 1 square? You do x minus 1 times x minus 1 times x minus 1. That's what you will be doing there, okay, to find out the point of intersection. So you will get x minus 1 is equals to, if you FOIL this, you will get this x cubed, okay, minus 3x square plus 3x minus 1. That's what you will get if you do x minus 1 to the cubed, not square, it is cubed. Okay, now if you add 1 on both sides, what do you get? Plus 1 and then subtract x minus x minus x. What do you get? That will cancel out and then that will cancel out as well. So basically you will get this x cubed minus 3x square plus 2x equals to 0. Again, we want to find out the point of intersection. We need to solve for x to find out the point of intersection. Why do we need point of intersection? We will need to plot the limit, right? For this piece, that gx is bigger than fx. On this piece, fx is bigger than gx. That's why we need to find out that that boundary for each of those pieces. So to solve this, since all these terms have x in common, let me take x out. What do you get? X squared minus 3x plus 2 equals to 0. Now you get x and then x minus 2, x minus 1 equals 0. Because inside the parenthesis, you need two numbers whose sum is -3, product is +2. That is -2 and -1. So if you solve this, you'll get x equals to 0, x equals to 1, and x equals to 2. You see that? This is x equals to 0, this is x equals to 1, and that point is x equals to 2. So the area between fx and gx in the interval 0 to 2 is, you can write closed interval, not a problem, okay, is a equals, let's find out this part, this shaded region, that is x is running from 0 to 1 because that is 1. So 0 to 1, which function is on the top? Gx is on the top, right? G of x minus f of x dx, okay, minus, now another piece is 1 to 2, right? In this piece 1 to 2, the upper function is fx, so you write fx minus gx, and then dx is there. Okay, that's what you do. Okay, so let us plug in the values. 0 to 1, what is gx? Gx is x minus 1. X minus 1 minus cube root of x minus 1 dx. You see that? And then minus on that one, 1 to 2, cube root of x minus 1 minus x minus 1, and then dx. Okay, so you have a big parenthesis there. Now what you can do next is just plug in that, because do you know one formula? Because you can basically do it by using the substitution method. Okay, the formula is, if you have like ax plus b to the n, and then dx, if you want to find out the integral of that, that will be a plus bx to the n plus 1 over, oh sorry, ax plus b to the n plus 1, because you cannot move that a and b there. Ax plus b to the n plus 1 over a times n plus 1. That is the formula. If you do the substitution method, you can get that. If you do ax plus b equals to u, that's what you will get. Okay, now here it is basically what? It is basically x minus 1 to the 1/3, and this is also x minus 1 to the 1/3, right? So we will use that integral formula there. So what do you get there then? It is 0 to 1, x minus 1 to the 1. What is the integral of that? That is x minus 1 to the 1 plus 1, that is 2 over a is basically 1, right? So that will be 1 times 1 plus 1. That will be like, let me find out that. Let me write down that way first. X minus 1 to the 1 minus x minus 1 to the 1/3. That is cube root, right? Dx is here. That is the first integral. And then minus the second integral is, plus. Because we are dividing that into two integrals, right? Plus, you see that plus here? Upper function minus lower function, plus another upper function and lower function in this next piece, plus 1 to 2, x minus 1 to the 1/3, and then minus x minus 1 to the 1 here. Okay, and then dx. Okay, now you can use that formula. You will get x minus 1 square over 2 minus, that will be x minus 1 1/3 plus 1 is 4/3 over 4/3, but the limit is 0 to 1. That's what you get. Okay, and then plus, for this one you do the same thing. It will be like x minus 1 to the 4/3 over 4/3 minus x minus 1 square over 2, but the limits are 1 through 2. Okay, now you plug in 1. What do you get if you plug in 1? You get 1 minus 1, that will be 0. This will be 0. Again 1 minus 1 is again 0. So 1 minus 1. So if you plug in 1, it will be all 0, right? Now if you plug in 0, what do you get? You will get 0 minus 1 over 2. So 0 minus 1 square is negative 1 square is positive 1/2. Okay, that's what you'll get, 1/2 minus, so plug in 0, negative 1 to the 4/3. Okay, negative 1 to the 4/3 over 4/3. What do you get? What is negative 1 to the 4/3? You can write negative 1 to the square to the 2/3. You can divide like that, right? You see what I'm saying? I'm saying this one. Negative 1 to the 4/3 can be written as negative 1 to the 4 times 1/3. But what is negative 1 to the 4? That is 1. And 1 to the 1/3 is still 1, right? You'll get 1/4 there. That term will be 1/4 when you plug in 0. Similarly here, if you plug in 2, what do you get? 2 minus 1 is 1 to the 4/3 is 1 over 4/3 there, right? That will be plus 3/4, because 1 over 4/3 is basically 3/4. And then minus, plug in 2 again, 2 minus 1 to the square. So 1 over 2 minus 1/2. But if you plug in 1, you will get 0 again. So if you simplify that, you will get basically 1/2. That will be the total thing, because this 1/2 and 1/2 cancel. 3/4 minus 1/4 will be 2/4. That is basically 1/2. That is the final answer. Okay. By the way, I forgot to tell you one thing. That is, if you want to find out the integral of definite integral using calculator directly, there is a way to do that. Okay. So the idea is, suppose, say you want to do, let's say 1 to 2 and then x squared minus 5x plus 2 dx. How do I do this? So in your calculator, you may have learned that already in Calc 2, but I'm just telling you this. How do I do that? Turn on your calculator and go to math. Press math. Press math. When you press math, you will see frac, decimal, cube, and cube root, and so on. But if you go to number 9, you will get f integral, and then go to fn and then integral. Press this. If you press this, you will get integral, and then you will get a box here, you will get a box here, you will get a box here, and then you will see dx. Okay, if you press that value, you see that, or there you might see box here as well. If you have a TI-84 latest version, you will have a box here as well. Okay. So if you want to do that, then how do I calculate that then? So you see that you enter 1 here, you enter 2 here, you enter x squared minus 5x plus 2 here, and then that is dx. So if you want to find out like y squared minus 1 dy, 0 to 5 like this, and do the same thing. Press math and then f integral, and then on that you have this and then that and then d and then that, right? So you enter that thing. So 0, 5, y squared minus 1, and then y. You can do that too. Okay, but x and y, you'll get the same answer actually. Okay, so you can basically find out the definite integral directly using calculator as well. That's what I wanted to mention. Okay, guys. So let us see some more examples from the book. So the next example I want to do is question number 33. Example is question number 33 from the book. It is saying that use graphing utility to graph the region bounded by the graphs of the function. Find the area of the region analytically and use the integration capabilities. So integration capabilities is basically, it is asking to use the calculator. Okay, calculator use the numerical method to integrate. That's what it is saying. Okay, so so the next thing we want to do is question number 33. All right, guys, let us do that. So the function is fx is equals to x to the 4 minus 4x squared, and then gx is equals to x squared minus 4. So if you use if you use calculator to graph it, if you use the calculator, you will plug in y1 equals to x to the 4 minus 4x squared in your calculator, and then y2 equals to x squared minus 4, and then graph it. Okay, if you graph it, this is what you will get. So I may not be very accurate on that, so I'm just looking at my calculator. Okay, so x squared minus 4 will look like this. That will be the x squared minus 4. Okay, and then the other function, other curve, will look like the x to the 4th minus 4x squared will look like this. Let me use different color for that. Okay, if I use that, then you will see like this. Okay, so this is basically fx, and then the other one will be gx. So you want to find out the area between them. That means you want to find out that area, and that area, and then you will add them. So this is -2, this will be positive 2, this will be positive 1, this will be negative 1. Okay, but we need to find out what are those point of intersection here. Okay, how do I find out that? Because at that point, at these 4 points, this point, that point, this point, and that point, these two functions are equal. So to find out the point of intersection, we set them equal. Okay, so how do I do that? You do x to the 4 minus 4x square equals to x to the square minus 4. Okay, what do you get here? You get x to the 4 minus 4x square minus x square and plus 4 equals to 0. That is basically x square, x to the 4th minus 5x square plus 4 equals to 0. So this happened to be easy, right? You can do x square minus 4 and then x square minus 1 equals to 0. You can factorize like this, right? If you solve it, you will get x square minus 4 equals to 0. That implies x equals to plus minus 2. That is minus 2 and plus 2. Similarly, x square minus 1 equals 0 implies x equals to plus minus 1. That is plus 1 and minus 1. These are the point of intersection. Okay, so now what we'll do is for each of these p's, okay, we'll find out the integral. All right, so what I'm going to do here is I am going to do, and also there is another way, like little shorter way. What you can do is, you see that left side and the right side are the symmetrical, so you can just find out the area of the left side and multiply by 2 to find out the total area. You can do that way too. Okay, you see what I'm saying? So what I was saying here is, you can do either way. Area equals, so you can do negative 2 to negative 1. Which function is higher, bigger? G, right? So g minus f dx. We'll plug in the value of g and f, plus negative 1 to positive 1. You do f minus g dx, and then plus 1 to 2, and then again g is on the top, right? So g minus f and then dx. You can do that way, or you can do negative 2 to negative 1, the same thing, and negative 1 to 0, that is 0, right? And then multiply f minus g, okay, and then multiply that area, whatever you get, by 2. That's what you get. Okay, all right. So if you do negative 2 to negative 1, negative 2 to negative 1, what is gx? Gx is x square minus 4. 4 minus f is x to the 4th plus 4x square. Why? Because I'm just distributing this negative sign to both of these. I'm doing minus f will be negative x to the 4 plus 4x square dx, plus negative 1 to 1, it is f minus g, x to the 4 minus 4x square minus x to the square plus 4. Again I'm doing minus g, so minus x square plus 4, and then dx, and then plus g minus f again, so x square minus 4, and then limit is 1 to 2, right? Minus, and then x to the 4 plus 4x square. You see that? And then dx. So you can integrate each of them integrate, or just use calculator. In the calculator you do just go to the math and then scroll down, okay, and then dx, scroll down, go to the math and then scroll down and then dx. Do the same thing for this integral, and then like that, dx, and then plus again go to the integral for this one, and then do that one, dx, and find out those values and add them together. Okay, so you can find them separately and then add them together after you finding that, this thing plus this thing plus this thing. So if you do that, you will get basically the final answer will be 8. Okay, so either way you will get your answer as 8. Okay guys, all right, that's how you do question number 33 from your book. So the very last example I want to do is, if there is a trig function, how do you do that? It's the exactly same, integral fx minus gx. Okay, so I'm going to do question number 44 from the book. Okay, on question number 44 there are two trig functions. That is, one is y equals 2 sine x plus cosine 2x, and then another is y equals to 0. That's what it is. Okay, y equals to 0. So it asks you to draw the calculator, draw using the calculator, and then let me write down the question first. 44. So f of x is given as 2 sine x plus cosine of 2x, and then another curve is y equals to 0, and then 0 is less than x is less than pi, or less or equals to pi. That's what it is given. So if you use calculator to the other graph for this function, so this is, let's say this is pi, okay, and then so when you do this, you need to do the degree mode there if you want to draw with the pi, okay. And if you draw the graph, if you just into that 2 sine x plus cosine 2x, I think it will pick that automatically, and you can draw that limit at 0 to pi in your calculator. Just press window and then fix x minimum is 0, x maximum is pi, okay. If you do that, you will get this. You will get your curve will like this, and you want to find out that, okay. So what is the bottom function? This is y equals to 0. This function is y equals 0, and this function is f equals to 2 sine x plus cosine 2x. Okay, that's what you do. Now what is the area then? Area will be what? Integral 0 to pi. That's what 0 to pi. That's what 0 is, right? And then 2 sine x plus cosine 2x, and then dx. So what is the integral of sine x? Negative cosine x, right? So it will be negative 2 cosine of x, and then plus, what is the integral of cosine x? It is sine 2x over 2, and 0 to pi. We know how to find out the integral of cosine 2x. You can think that as u. That is u. Or if you don't want to use that u substitution again, that's the formula. Formula is cosine ax dx will be sine ax over a plus c. Okay, that's the indefinite integral. For the sine, it will be negative cosine. For the cosine, it will be positive sine. That's what the integral is. Okay, now plug in that pi here. So what do you get? You will get negative 2. Cosine pi is negative 1 there. Okay, and then plus sine 2 pi is sine 0, which is 0. Now plug in 0. What do you get? Minus negative 2 times cosine 0 is 1, and then plus sine 0 is 0. So if you do that, you will get 2 plus 2, that is 4. That's what you get. Okay, so there are some questions like on 37 through 42. There are different types of problems there. Okay, so you can basically do similarly, just do fx minus gx, and then, because for example, if I do question number 39, there is 2 sine x is fx. Okay, on question number 39, 2 sine x is fx, and then another function is tangent x. Okay, 2 sine x and then tangent x. So you can do that problem similarly. Okay, it's not different at all. Just you can do, for example, if I write 39, it says fx equals 2 sine x, and then gx is equals to tangent x, and it's saying between negative pi third over pi third. So negative pi third is less or equals to x is less or equals to positive pi third. Just do fx minus, you draw the graph first, and then do fx minus gx or gx minus fx, whichever is on the top. Okay, and then find the integral. So fx minus gx or gx minus fx, negative pi over 3 to pi over 3. If they intersect in between, at a point between negative pi third and pi third, you need to break like we did here. Okay, otherwise just do the regular way. Okay guys, that's all from chapter 7.1. Thank you guys.